Hi, welcome to the series of videos aimed at looking into the practical aspects of Cisco's model-driven telemetry. So before we delve into the practical aspects of how to utilize Cisco's model-driven telemetry, in part one of this video series, we are going to take a look at the basics and some essential theory that everyone should know in order to dive deep into Cisco's model-driven telemetry. So before going into the model driven telemetry, we need to understand what telemetry is, right? So, but for all the network engineers out there, we have been doing telemetry all this while. We can sort of understand SNMP, NetFlow, and syslog, all these protocols, to have done some form of telemetry all this while. So, a little bit of definition. Telemetry is an automated way of collecting and communicating the collected data to a remote location for monitoring. So that's what we have been doing. SNMP does the same. And in NetFlow, we have been shipping that data to a centralized location wherein we are doing some form of flow analysis. And syslog also is the same because we are analyzing events and whatnot through a centralized, log monitoring solution, say for example, Splunk. So moving on, so what do we expect in a modern telemetry solution that is sort of aimed at replacing SNMP? Because MDT focuses on statistics. It's typically we don't use it for event-based, telemetry, right? So this, although we can use MDT for that, it sort of the main motivation is to replace SNMP and sort of replace it with a newer and faster protocol. So the features that we would want in MDT are that it should be scalable and it should be real time, capable of shipping the data in real time. And the third and most important, I would say, is that once that data is shipped to a centralized location, that data should be analytics capable, right? And we need to have granular control over the metrics that we would ship from that network device all the way to that central location. So all of these are all the features that we would want. The name itself suggests that it's model driven telemetry, right? So the important aspect is that we should be able to model the data, the operational data that we're going to send from that network device all the way to the central location. So the data should be capable of sticking to that particular model so that both the sender and receiver agree on that particular model and we can do analytics on top of that. So typically the model driven telemetry, these are all the features that are there. One, it gives us the mechanism to stream data, and historically when people compare it with SNMP, it has been shown that the utilization of CPU as the data volume grows, in that case MDT really performs well. So the third important feature is we should be able to achieve push-based mechanism through MDT. So this is ideal for large amounts of data. In that case, we do not want a central entity to be polling for that particular data. We should have the ability to send data at whatever interval we please out of that network device to that central location. And finally, the structured data streaming that we saw in the motivation, that is possible courtesy YANG, which is the same model that we use for configuring devices through netconf, right? So what are all the supported OS when it comes to Cisco? Because we are especially looking at Cisco's model driven telemetry. So iOS XC and XR, they are supported. NXO is the data center operating system, also support MDT. But in these series of videos, we are going to basically focus our efforts on XC and XR based implementations. So For people who have been doing netconf based configuration management, models are not new, but for people who are encountering this for the first time, so there are two major types of models. So by model I mean how that data is structured, right? So how do you define what are all the parameters, what are the key types and all such things. So that's basically the essence of data modeling, right? So there are two major types of models when it comes to Yang models. So one, they are the open config or the open models. They are the vendor agnostic models, and the other is the native models, which are typically released by the vendor, and they don't conform to all possible network devices. It's only for that particular vendor. So where do we get access to all these models? So I have flashed that link there, and you're free to go and have a look, because these are all open source. Let me take you to those Yang models. So this is the GitHub page of Yang models. So if we go into the repositories, so we can see that there is a public repository called Yang, and one it's pretty straightforward, and we can see that there are some vendor based folders, and the one that we are interested in is the Cisco. So let's take an example of XR. Suppose your devices, if they're running 733 version of iOS XR, let's go into that folder, and you can see that a particular folder called 733 has all the .yang files that are supported by that particular version. So let's take an example of some random model. So if you click into a particular Yang file, we can see the exact text of that particular Yang model. So we'll not dive into the details of this Yang model, but this is basically to give you a reference on where you can find all these models. You can basically clone this repository and keep it for reference. In future, when we're going to take a look at the practical aspects, we'll definitely take a deep dive into the models and how we can ship our operational data specific to certain Yang models. So coming back to the theory, so how the data is shipped from that network device all the way to the analyzer. So this is what you would typically find in any standard MDT implementation. So there is this network device. So this MDT capable network device. So this MDT capable network device sort of pushes the data, the operational data, onto the collector or the receiver, and the collector or receiver basically parses that data and then writes that data onto a time series database. So typically you would want to use a TSDB because those are the databases which are optimized for this particular type of data. So once the data is written on to this TSDB, we can basically analyze that data using any graphical analyzing tool. So there are many open source stacks that come to the rescue of MDT. So the one particular stack that we are going to look at this set of videos is the TIG stack, or the expansion of that would be Telegraph, InfluxDB, and Grafana. So the Telegraph and InfluxDB both corresponds to an both are the solutions of a company called Influx. So they are both open source, although there are paid implementations of InfluxDB, the commercial or the enterprise versions. One can typically obtain both these solutions for free. And one more open source solution is Grafana, and Grafana corresponds to the analyzer part. So basically, to give you a reference, the collector or receiver role would be performed by Telegraph. The database role or the TSDB that we are going to that we are talking about is the InfluxDB here. And to analyze that data, we are going to utilize Grafana, right? So transport and encoding options, what we need to know, just sort of basics to get things started, is that, typically when you push that data on from that network device all the way to that analyzer, so we need to be selecting certain encoding and transport options, right? That sort of defines what is sent over the wire. So encoding is typically used to represent whatever data that we have modeled. So when it is put on the wire, what is the sort of structural representation that we would use? And we should carefully choose the encoding based on the compression levels that we would want. So the more the compression, the less bandwidth it would use on WAN. So we have several options. We need to look into the config guides of that particular OS in order to select the best possible encoding and transport pair, right? So that's the basic thing that you need to know about transcoding and transport and encoding options. So some of the salient points to just get kickstart the journey is that what would you typically use, dial-in or dial-out? So dial-in and dial-out, these are the two types of options that we have when it comes to configuring MDT. So as it's pretty clear, dial-in is that configuration when the collector sort of dials into the network device. You can sort of compare it with SNMP, where that centralized network management solution sort of polls that network device and then gets the relevant data. On the other hand, dial-out is when the network device sort of pushes the data to that centralized collector. So for obvious reasons, the MDT solution that we are going to take a look at is the dial-out version, right? So if an example, if you take iOS XE implementation of dial-out, so we are going to take at the YANG based implementation. So we are going to do a push mechanism, and the encoding that we are going to use is KVGPP. So this is an example of the group of settings that we would use if we are going to go for the dial-out setting, and you can basically sort of find this in the config guide. So when we're going to work with the models, one very good tool that Cisco has given us, which is also open source, is YangSuite. So YangSuite is sort of a tool that would let us explore all those models and then sort of find the relevant operational data, so that we can test, validate our configuration, and then sort of finally push that configuration. It's used for multiple needs, but we can use that for finalizing our configuration when it comes to MDT. So it's sort of complete API testing and validating environment. So these are basically the settings that we should know in order to just kickstart our journey into MDT. So hope this presentation was useful, and I would like to see you in the next set of videos wherein we take a look into the practical aspects of MDT. Thank you for watching.